folks, this is going to be a longer video today looking at logarithms, trying to answer the questions of what is a logarithm, how do I use them, how can I practically use this tool to solve problems in mathematics. So hopefully you know a little bit about logs, but if you don't, a logarithm asks the question of what power. If I was trying to solve this equation, 2 to the x equals 32, all right, there is a whole number power of 2 that will equal 32, and I might get there just by multiplying them together. You know, if I needed to, I could do 2 to the 1 is 2, 2 squared is 4, 2 to the third is 8, and I'd eventually get 32 as 2 to the fifth, 5 2's multiplied together, and that's one way I could solve this problem. But what if I asked you 2 to the x equals 31? Now this is no longer a whole number power. I know that there is one, like 2 to the 4 is 16 and 2 to the 5 is 32, so it's reasonable that there is some power that I can raise 2 to and get the number 31. But is it 4.5? Is it 4.8? Is it some ridiculously long decimal that has 50 million places, or something that's even an infinitely non-repeating decimal, an irrational number like pi or the square root of 17? So how I find that is by using a logarithm. A logarithm is simply defined as the exponent that I put on a base to get a certain outcome. If I say the base b log of a equals c, that is the same. That expression, that writing has the same meaning as saying b to the c equals a. So if I just follow along at what I've got, I have 2 to what power equals 31. I'm just going to put those numbers in the right place. Here's a big clue. The number that is on the bottom of something, b to the c, ends up in the bottom of the logarithm. And I'm just going to write this here for you. This is called the base b log of a. That's how you read that. A lot of students will say, what's the base, or what's the log to 8? Okay, I know what you mean. But the right way to say that is the base 2 log of 31 equals x. And you're like, well, that's great. Now I know how to use this word, but that doesn't help me actually solve the number. Find that value. If you have a TI-84 family calculator, you want to look for the math button that is on the left side of your calculator button pad, and then hit the math button and scroll all the way down until you see something called log base. I believe it is A. I believe it's letter A in that menu, and when you type that button on your calculator screen, you should get something that looks like this. Now remind ourselves, we were looking for the base 2 log of 31. So you're just going to type in 2 over there. You're going to put your cursor over that little box and type 2. Put your cursor over the big box and type 31 and hit enter. When I do that on my calculator, I get 4.95. Well, it's actually 4.95 followed by a lot of other decimal places, but this is consistent with what I was expecting, a decimal answer between 4 and 5. That's how you use the log base feature. Let's say you can't find the log base feature, or you don't have a TI-84 or better calculator. You should have 2 buttons on your home screen, or on your button pad of your calculator. One just says log without any kind of number on it, any kind of way to add a base. And then one is this guy ln, which is the natural log. And the natural logarithm. He's actually the best one. When you get to calculus, you will understand why natural log is the best of all of the logarithms. It doesn't actually take calculus to understand why, as long as you understand that e is the best base of things. So the natural log is a base e log. This guy we call the common log. If there is no number written there, the common log or the common logarithm, that's the default base that we see is 10. I'm going to quick show you how to use these 2 buttons to evaluate a log of a different base. This is called the change of base rule, and then we'll do some problems where we're going to use logs in creative ways. Okay, change of base rule. This is what we used to have to do in our calculators back in the dark ages when I was in school if we wanted to evaluate a logarithm of a base that wasn't e or 10. But now there's that button, log base, where you can actually change the base. Okay, so choose your favorite log. We were looking for the base 2 log of 31. I want you to pick either common log, log, or natural log, ln. I'm going to choose natural log, ln, because that is my favorite. And you divide them. I'm going to take the natural log of 31 divided by the natural log of 2. Go ahead and type that in your calculators, and you should get, again, 4.95. Notice that you could do the same if you type it in as common log of 31 divided by common log of 2. You will also get the same answer. Okay, and again, as long as the base goes in the basement, the things that was on the bottom, that 2 that is in the bottom of the log expression goes underneath the dividing sign, it remains in the bottom of the fraction. As long as the base stays in the basement, you can use this change of base rule to evaluate logs. This is a consequence of the third log law. I have a whole other video about the properties of logs, or log laws as they are, and I encourage you to check that out if you want more explanation on that guy. Okay. So now we know how to evaluate logarithms and what they mean. Let's take a look at just a couple of different problems. So if I ask you, let's say this is a non-calculator thing, and I ask you what is the, I don't know, the base 5 log of 25. This is definitely a quiz question I would put on a quiz on a non-calculator section. So I just remind myself, what does the definition of logarithm mean? Well, 5 stays on the bottom. 5 to the something equals 25. Oh, it's 2. 5 squared is 25. So the base 5 log of 25 is 2. That's how we handle those problems. You might get some fun ones, like what's the base 49 log of 7? So that's like asking 49 to what power equals 7. And you have to remember the square root is like saying to the 1/2. 49 to the 1/2 equals 7. Or I could ask you something that uses another kind of unusual exponent. What if I ask you for the base 4 log of 0.25? So that's asking 4 to what power is 0.25? And again, you might recognize that as a fourth. 4 to what power is 1 over 4? That's -1. 4 to the -1 equals 1/4. Right? A great common question that's often asked on tests or homeworks or things is pick whatever number you want. I'm going to pick 8,326. The base 8,326 log of 1. That's asking what power do I raise this number to get 1, and it's 0. Anything to the 0 power is 1. And so no matter what this is, no matter what that base b is, this expression is true. Now I should qualify this by letting you know we insist that the base is greater than 0, because otherwise the logarithm is not well defined. And you'll notice that if I asked a question like, let's even just do a base 10, nice base 10 log of negative numbers. 10 to what power is a negative number? That should make you feel a little funny. There's no number of times I can multiply 10 by itself and get a negative output. So there is no answer. This is undefined. And it turns out that the base b log for any b, the log of x, has a domain of strictly positive numbers, not even 0. 10 to no power will ever equal 0. So the base of this expression, or you can think of that as the possible inputs that I could ask, are only values that are greater than 0. Okay, let's go back up here, and we're going to ask another couple questions. How problems might appear, right? This is like the most common way that problems appear when you're using logarithms. When you're actually trying to solve for the x that's in the exponent, I encourage people to think, if you ever feel like you're going to take the xth root of something, you know, if I had like x to the 8th equals 100, I would solve that problem by doing the 8th root of 100. If you ever feel like you want to take the xth root because the x is in the exponent, that means you mean a logarithm. Right? But logarithm problems appear in ways that don't have anything to do with solving for the number that's in the exponent. For example, sometimes I could ask a question like this, or pose an equation like this. Let's say the base 2 log of x equals 3. And my job is to solve for x. Well, before I think too hard about it, I usually suggest that you rewrite this. 2 to the 3 equals x. Get the log out of there. And that's as easy as figuring out what 2 to the 3rd is, which you could do on your calculator. Also, sometimes these expressions are asked with the x in the base. What if I asked, let's see, x to the base x log of 81 equals 4, and I'm trying to find x. That gives me this expression, x to the 4th equals 81, when I rewrite it without the logarithm. And this is a matter then of taking a root. X is the 4th root of 81, which if you type that in your calculator, you'll get 3. I would be tempted to say, right, the 4th root of 81, if I just asked for that, my answer would be plus or minus 3. But remember that a number in the base of a log can only be a positive answer. So you only just pick the positive answer. That pretty much wraps up how logs are seen in problems until you get to properties of logs. So after you've learned this section, your next section is probably properties of logs or log laws or logarithm properties, something like that. I have a whole other set of videos for those, and I encourage you to look them up. Thanks for watching.